Okay, thanks a lot. So I'm here to present our work. It was basically done by Polyxeni and Tarek. I was the supervisor. So Michael asked me, can you participate in this venture? And I said, it's so hard in summer. I'm not there. But we found 2 students and they were actually really good. And it was surprising for me, especially what actually came out. And we discussed a lot about it. So I want to share that experience a little bit with you. So the main idea was not very well defined. I mean, I think this was the main idea of the task. So we didn't get a clear definition what we wanted, and we could make our own sense of it. So immediately I thought of this Perscheid cartoon, which is Perscheid is one guy that copies Gary Larson more or less, but in German. So I tried to translate now in stores genuine movie theater experience for home users, and actually shows that some people really want to go to the movies and some people really don't want to. So Martin Perscheid most likely doesn't want to go there. And so it's hard because the context of watching something on the plane is different for every individual. So what we tried is which movies go well on an airplane. We wanted to understand the data a little bit, understand the context, and we want to create an understandable approach, which doesn't go very well with machine learning, of course, because we have to clearly understand what the system is doing then. Yeah, and we wanted to use common methods in visual retrieval and in machine learning. That was our idea. Okay, and yeah, we all know we can't get around that. So we had to use convolutional neural networks features. It was especially hard for me because I'm the guy with Lire. Says so here. So I refrained from using Lire. I knew that the other groups would do it for me, like Konstantin. And Tarek made his way in a few weeks through the whole CNN topic and used a model, took out a layer and created a descriptor per image of 1024 dimensions. And well, that's a deep dream image of the medieval cake, actually. And we're thinking of which image goes well on those slides. That's a deep dream image of medieval. So the computer dreams of medieval. Okay, and we had to submit 1 visual run at least, so we decided to submit 2. And we decided to make the distinction based on the source. So for the first thing was, okay, it's movies, we need the trailers, we go for the trailers, that's clear. But what in my sense was more obvious, and this was one of our first points of discussion, that the posters are a better source. Because I think the posters convey the whole story or sell the whole story of the movie in one still image. Actually, and that's also the thing where people decide. So when you go to the system, then you take a look at the movie and they don't hit show me the trailer, but they decide based on one image and a little bit of text. Most likely you don't read the text. So the poster sells the main movie concept in one still image, and so we tried to use that for the first run. And of course we needed to use the trailers, and you're a little lazy bunch, so we just took out 200 frames, equidistant, and concatenated them and fed them to a SVM. So we didn't do anything fancy, but just took out 200 frames, and so we had the same dimensions for every trailer, fed that to an SVM. Okay, the most surprising thing about that was that posters and movies were not, the posters and the trailers were not agreeing at all. I mean, nearly half of the data that was classified as true positive, or as positive or as negative from one was classified the other way by the other algorithms. Posters and movies didn't match well. We didn't try the fusion part. That's Tarek is still working on his master thesis, so that's something he will do in the next week. And we had, on the other hand, we had the text-based run. So Polyxeni, she's not a computer science student. She tried to do everything based on text, and she wanted to go to audio then, but we left it out. It took her too much time. And we discussed a lot what we can actually do. So we had the text from the XML-based metadata, and it was clear that we could use that with stop word removal, a common stop word list, and a Porter stammer. We came to 1,972 distinct terms, and we used a naive-based classifier. So that was the main idea. And to fill this up, we had the first run with Bing search results. So Bing has a nice API. We added up to 5,000 terms all in all. We got the rest from Bing search results. And for the run number 4, we fetched the data from the IMDb, plot synopsis and keywords, and again ended up with 5,000 terms. And we selected them based on their term frequency, or actually the whole weight, term frequency inverse document frequency. So it's rather straightforward, beside the cut in the dimensions. Okay, that's arguable. But what we thought of was that actually the only thing we can really derive from the context as heuristics would be the no-goes. So which movies don't go at all. And based on text, we had a lot of brainstorming, and we came out with the idea that anything that goes about airplane crash, airplane attack, hijacking, Air Force One, bomb, terrorist, kidnap, abuse, and fascism wouldn't go there. I don't know what fascism actually does there, but Polyxeni did the work and she came up with it. But the idea was then to reduce the false negatives. And that's also the difference to the other submissions. We first classified it with the machine learning approach, naive-based classifier, and then we checked if the terms from the no-go list are in the term vector, and if we found 2 or more, we automatically moved it to the negatives. Because we really didn't want that people are shown movies they shouldn't see, and the recall wasn't that interesting for us, so we were out for precision, kind of. And in this case, you see the disagreement between the two methods, the Bing-based term filling and the IMDb-based term filling. There's a larger agreement, so only in 15.7% there was a disagreement. And when I made this slide, I thought, wow, that's cool, finally I made a slide that looks like Pac-Man. Okay, so that's more or less the disagreement all in all. As you can see, the text, because I thought now I have the disagreement between visual and the disagreement between the text ones, so I have to do the whole matrix. And it looks that only the disagreement between text 1 and text 2 is rather small. Everything else is, yeah, disagreeing a lot with each other. The overall results are not too bad, I think. I mean, the method is rather simple. It shows again that the text actually works best, but only by a small margin. But the problem is that we cannot really judge on the margin because it's only in the test data set, it's only 223 movies. So if it's a significant result or not, let's not start arguing. What we really tried is to reduce the false negatives, the false positives, and as you can see in the text, it actually worked out very well. And with the posters, it worked out actually the same way. Okay, that's it. Any questions? And you definitely should use your